subject matter is so fascinating to me. So first, please explain what this idea of assembly theory.
Yeah. Assembly theory is born out of an interest in solving the origin of life and finding aliens. So that's sort of the motivation. I think it's really important to be clear about that to start, because it introduces some kind of radical reconceptions of the way we think about fundamental physics, at least I think so. But the key idea of the theory is that the universe cannot generate complexity outside of living processes. And so we have a way of formalizing what seems kind of intuitively obvious, that the universe doesn't generate complex objects for free. And we do this with this idea of assembly theory, of thinking about the assembly space, which is like the space of all constructible objects. And you can talk about the complexity in that space as a minimal number of steps for making an object. And if you see objects that require a lot of steps to make them and they're in high abundance, life is the only thing that can make them.
Wow. So this includes plant life. This includes
everything, technology, everything on your table. You know, requires billions of years of evolution of intelligence, and technology to generate. So
when you say life to generate, what about like crystals? And what about, have you ever seen that enormous cave in Mexico where they have these insane crystal structures?
Is that the one that's like hot inside and like?
Yes.
Yes, I have seen that. It's gorgeous.
Amazing.
I've never been there. But
amazing.
Yeah, totally.
But it kind of looks like somebody made it, but it's just natural processes.
Yes. So I'm actually really interested in understanding to what degree we can consider minerals on our planet alive or artifacts of life. But we haven't formalized the theory entirely for minerals yet. So I think that one of the sort of key results we have so far is actually quantifying in molecules a complexity boundary above which, if a molecule is so complex that we can say it's definitively of life, and we've experimentally verified measuring this property of assembly of molecules to say these are derived from life, these are, and that there's a clear boundary. For minerals, we haven't done that yet because we're still formalizing the theory and the kind of measurements we need to take. But I expect there to be a boundary that planets can make some kinds of crystal complexity, but not all of it that we see on this planet.
So what's the conventional definition of life?
Yeah, so there's a lot of debate about what definitions of life should hold, but the one that is usually cited by astrobiologists is life is a self-sustaining chemical system capable of Darwinian evolution. And I've memorized it because I find it so annoying. So I'm like, I got it down. I got to know what I'm annoyed with.
What annoys you about it?
Everything. It's like, actually, it was very funny writing the book because I wanted to get into the new ideas, and my editor was like, you got to explain how people think about life now. And I was like, okay, well, this definition is the most annoying one. I'll just pick it apart. And it's actually like all the words in it are annoying in some sense. So the first one is that life is chemical. I've never really thought about chemistry being the defining feature of life. I think you have to separate out that life emerges, at least as we understand it, from a chemical soup on a planet, right? So it emerges in chemistry, but it doesn't mean it's a chemical phenomena. And the sort of analogy from the physicist's conception of nature I could draw there is we don't think that gravity is a phenomenon of rocks. Gravity represents some universal physics in our universe. And so when we're thinking about planets and things, we don't think that they obey the laws of gravity because they're made of rocks. We understand that there's some property called mass that's much more abstract and applies to everything. I think life's kind of the same. It emerges in chemistry, but there are some informational properties, these things about how life generates complex structures and how it does that so uniquely, that is universal physics that happens to emerge in chemistry. So chemistry has to go out. It's not just a chemical phenomena. And I think you need to recognize that if you're going to talk about like technology and artificial intelligence and like, are they alive or not? Because they're very